Lesson: AI-driven Security Orchestration, Automation, and Response SOAR. The integration of AI-driven security orchestration, automation, and response tools into the Security Operations Center represents a transformative approach to managing cybersecurity threats. These tools enhance the SOC's capabilities by streamlining processes, improving response times, and reducing human error, ultimately optimizing the security posture of organizations. This lesson delves into the actionable insights, practical tools, frameworks, and step-by-step applications that cybersecurity professionals can implement to leverage AI-driven SOAR effectively. SOAR platforms serve as the backbone for modern cybersecurity operations by orchestrating various security tools and automating repetitive tasks. They consolidate alerts from multiple sources, enrich them with contextual information, and facilitate automated responses, thereby reducing the burden on security analysts. AI plays a crucial role in this ecosystem by applying machine learning algorithms to analyze vast amounts of data, identify patterns, and predict potential threats. For instance, a study by Gartner reveals that organizations using SOAR solutions can reduce the mean time to respond to incidents by up to 70%. Among the practical tools that exemplify AI-driven SOAR capabilities, Splunk Phantom and Palo Alto Networks Cortex-XSOAR stand out. Splunk Phantom provides a flexible platform that allows security teams to automate repetitive tasks through playbooks, which are sets of automated workflows. The AI component can analyze historical data to predict incident trends and suggest appropriate responses. Similarly, Cortex-XSOAR integrates threat intelligence management with incident response, utilizing AI to prioritize incidents based on their potential impact. These tools collectively enable SOCs to handle a larger volume of incidents with greater efficiency. Implementing an AI-driven SOAR strategy involves several key steps. Initially, organizations must assess their existing security infrastructure to identify gaps that SOAR can address. This assessment should include an inventory of current security tools, data sources, and workflows. Next, defining clear objectives for the SOAR implementation, such as reducing MTTR or improving threat detection accuracy, helps guide the process. Once objectives are set, selecting a suitable SOAR platform that aligns with the organization's needs is crucial. Factors such as integration capabilities, scalability, and user interface should be considered during this selection process. After selecting a SOAR platform, the next step involves integrating it with existing security tools and data sources. This integration is critical, as it enables the SOAR platform to collect and correlate data from diverse systems, providing a comprehensive view of the security landscape. Once integrated, the focus shifts to developing playbooks that automate routine tasks. Playbooks are the heart of any SOAR solution, as they define the automated workflows that respond to specific incidents. These playbooks should be designed to handle common threats, such as phishing attacks and malware infections, and can be continuously refined based on feedback and evolving threat landscapes. AI-driven SOAR platforms also play a pivotal role in threat intelligence management. By ingesting threat data from various sources, such as open-source feeds, commercial providers, and information-sharing communities, these platforms use AI to enrich and prioritize intelligence, ensuring that security teams focus on the most critical threats. This capability is particularly valuable in addressing advanced persistent threats and zero-day vulnerabilities, where timely and accurate intelligence is crucial. A case study by IBM highlights how integrating AI into SOAR can enhance threat intelligence capabilities, enabling organizations to detect and respond to sophisticated attacks more effectively. Moreover, AI-driven SOAR solutions facilitate collaboration between different teams within an organization. By providing a centralized platform for incident management, these solutions break down silos and enable seamless communication between IT, security, and compliance teams. This collaborative approach ensures that incidents are addressed holistically, considering not only the technical aspects, but also the business implications. For example, a financial institution implemented a SOAR platform that integrated with its ticketing system, allowing IT and security teams to collaborate on incident resolution, resulting in a 50% reduction in incident resolution time. To further illustrate the effectiveness of AI-driven SOAR, consider a scenario where an organization faces a phishing campaign. Traditionally, security analysts would manually investigate each phishing email, a time-consuming and error-prone process. With a SOAR platform, the process is automated. Incoming emails are analyzed using AI algorithms that identify phishing patterns, and suspicious emails are automatically quarantined. The platform then triggers a playbook that notifies the security team, updates threat intelligence databases, and even initiates a password reset for affected users. This automated response not only enhances efficiency, but also reduces the risk of human error. While the benefits of AI-driven SOAR are substantial, organizations must also address potential challenges. One such challenge is the integration of AI models with existing systems, which may require significant customization and fine-tuning. Additionally, the complexity of AI algorithms necessitates a skilled workforce capable of interpreting AI-driven insights and making informed decisions. Therefore, investing in training and development for security analysts is essential to fully realize the potential of AI-driven SOAR. In conclusion, AI-driven SOAR platforms represent a paradigm shift in cybersecurity operations, offering a comprehensive solution to the ever-increasing volume and complexity of threats. By automating repetitive tasks, enhancing threat intelligence, and facilitating collaboration, these platforms empower SOCs to operate more efficiently and effectively. As organizations continue to adopt these advanced technologies, the role of AI in optimizing SOC operations will only grow, making it an indispensable component of modern cybersecurity strategies. The integration of AI-driven SOAR not only strengthens an organization's security posture, but also positions it to proactively address emerging threats, ensuring resilience in an increasingly digital world.